देखो अब तुम लोग का नेक्स्ट पेपर है ये वाला पेपर का बहुत हिस्सा हो गया है थ्योरी ऑफ रियल फंक्शंस का। तो नेक्स्ट पेपर इज योर ग्रुप थ्योरी। तो इसको हम लोग देखा जाए थोड़ा। देखो फर्स्ट वी विल सी अबाउट बाइनरी ऑपरेशन। A binary operation star on a non-empty set S is a function from S cross S to S. Example, this usual addition plus is a binary operation on Z. This set Z is a set of integers. As n plus m belongs to Z for all nm in Z. मतलब अगर दो इंटीजर है nm तो उनका जो समेशन है वो भी इंटीजर होगा. That is why n plus m belongs to Z. Second, usual subtraction is a binary operation on Z set of integers. For any two integers mn in Z, m minus n will also be in Z. यानी कि दो इंटीजर का डिफरेंस भी सेट ऑफ इंटीजर में होगा. Another example, let X be a non-empty finite set, then union and intersection defined by A union B is equal to X such that X in A or X in B and A intersection B is equal to X such that X in A and X in B. Both are binary operations defined on Px. Px means power set of X, or you can say set of all subsets of X. So these are examples of binary operation. Next, binary structure. If star is a binary operation defined on a non-empty set G, then G star is called a binary structure. मतलब G इस G के साथ स्टार भी है, binary operation भी रहेगा. Only then we call G star a binary structure. इसके बाद आ जाओ definition of group. Let star be a binary operation defined on a non-empty set G, then the binary structure G star is called a group if the following axioms are satisfied. क्या है? पहला associativity होना चाहिए, यानी कि A star B star C is equal to A star B star C for all A B C and G. Next, existence of identity होना चाहिए. It means there exists an element E in G such that A star E is equal to E star A and this is your A for all A and G. This element E is called identity element of the group G. दो प्रॉपर्टी हुआ. फिर थर्ड है तुम्हारा existence of inverse, means for each A in G there exists B in G such that AB is equal to BA is equal to E. AB means A star B, BA means B star A. This B is called inverse of A and it is denoted by A inverse. This is called as A inverse. Note, if G star is a group, then composition of A, B in G is denoted by A star B. Thus, in a group, A star B belongs to G. For all A, B in G, this property is known as closure property. तो चार properties हैं: closure property, associative, existence of identity, and existence of inverse. Generally, most of the author denote AB in place of A star B, and in place of saying G star is a group, it is said that G is a group. तो G एक group अगर लिखते हैं तो उसका मतलब है कि G there is some binary operation on G. Next, Abelian group. A group G is called Abelian if AB is equal to BA for all AB in G. Means A star B is equal to B star A अगर है for all AB in G, then G is called an Abelian group. This property is also called commutative property, and Abelian groups are also known as commutative groups. Sometimes we call Abelian groups as commutative groups. अब कुछ examples देख लेते हैं. Examples of group देखो. Example 1, set of integer Z with respect to usual addition is a group. This addition is star. So we see the following properties. First, closure property. Take mn in Z. दो integer ले लो Z में, then m plus n will also be an integer, because it is integer plus integer and integer. So m plus n belongs to Z, hence mn plus n belongs to Z for all mn in Z. Closure property hold हो गई. Next, associativity. We know that addition is associative in the set of real numbers and set of integers is a subset of set of real numbers. तो जो set of integer है real numbers का के set का subset है, और real numbers के set में addition associative property है. Therefore, addition in set of integer is also associative. It means x plus y plus z is equal to x plus y plus z. ये bracket y plus z में रहना था, misprint हो गया. For all x, y and z. Next, existence of identity. Since 0 belongs to set of integers and 0 plus n is equal to n, this is equal to n plus 0 for all n in Z. Therefore, this 0 is the identity of Z with respect to usual addition. or you can call this 0 as additive identity of Z. Next, existence of inverse. Take n in Z, then minus n will also be in Z, because Z is set of integers. Is plus 3 in Z, then minus 3 is also in Z. And n plus minus n will be equal to 0, and it is nothing but minus n plus n. This is your identity. So minus n is the inverse element of n in Z. Also minus n belongs to Z for all n in Z. Hence inverse of each element of Z exists in Z. यानी कि जो Z है with respect to plus addition closure property भी hold करता है, associativity भी, existence of identity and existence of inverse. There is one more property, commutative property. Since m plus n is equal to n plus m for all mn in Z, therefore this Z is commutative group. It means Z plus is an abelian group. Fifth property एक additional ये hold करता है, therefore this Z plus group is an abelian group. Note देखो, in a similar way we can show that the following sets will form abelian groups with respect to usual addition. क्या क्या है? Q is equal to set of rational numbers, R is equal to set of real numbers, and C is equal to set of complex numbers. All these three are abelian groups with respect to addition. There is another example. देख लेते हैं. Show that the set of non-zero real numbers form an abelian group under multiplication. Non-zero real numbers चाहिए. Let R is equal to set of real numbers and R star is R minus 0. R में से एक element 0 निकाल देंगे, so it is R star. We have to show that this R star is a multiplicative group. Why? Because under multiplication we are saying the binary operation is multiplication. Let us see the following properties. देखो क्या क्या है. First, closure property. Take any two elements A, B in R star. Then A is non-zero and B is non-zero. Then A into B will also be non-zero. So A into B is a non-zero real number. It means AB belongs to R star. Hence AB belongs to R star for all AB in R. ये हो गया. Next, associativity. We know that usual multiplication is associative because A into B into C is equal to A into B into C. Therefore, associativity holds in R star. Second property. Third, existence of identity. Since 1 belongs to R star, such that 1 into A is equal to A into 1. This is your A for all A in R. Therefore, 1 in R star is a multiplicative identity of R star. And next, there is inverse, existence of inverse. Take A in R star, then A belongs to R and A is not equal to 0. Therefore, 1 upon A is also in R and 1 upon A is not 0. Therefore, 1 upon A belongs to R star such that A into 1 upon A is equal to 1 upon A into A. This is equal to 1, which is identity of R star. It implies that 1 upon A belongs to R star is multiplicative inverse of A in R, and A belongs to R star implies 1 upon A belongs to R star. Hence, multiplicative inverse of each element of R star exists in this R star. So R satisfies both properties. Next, there is another commutative property. Since AB is equal to B for all AB in R star, therefore commutativity holds in R star. Therefore, R star is an abelian group under multiplication. तो ये प्रूव हो गया कि R star एक set of non-zero real numbers form an abelian group under multiplication. एक और एग्जांपल हम लोग देख लेते हैं, पूछ देता है कभी कभी. Show that the set of cube roots of unity is an abelian group under multiplication. देखो, let G is equal to set of cube roots of unity. तो G में कैसे एलिमेंट हो जाएंगे? 1 omega omega square such that omega cube is equal to 1 and 1 plus omega square is equal to what? It will, ये तुम लोग के लिए अपना 11th का 12th का किताब से अपना चेक करो इसकी वैल्यू क्या रहती है. Let us construct a composition table for G with respect to multiplication. तो composition table कैसे बनेगा? 1 omega omega square horizontal, 1 omega square vertical. अब 1 into 1 हो गया, 1 into omega omega, 1 into omega square, फिर omega into 1 omega, omega into omega omega square, and omega into omega square omega cube means 1. फिर omega square into 1 omega square into omega is omega cube. This is 1, and omega square into omega square omega to the power 4 means omega cube into omega, so it is 1 into omega, so it is omega. Now we verify the following properties. First, closure property. Since each entry in the above table is a member of G, इसमें देखो जो भी entry है सब G का member है. Therefore, G is closed under multiplication. Next, associativity. Since multiplication is associative in set of complex numbers and G is a subset of complex numbers, therefore multiplication is G is associative. दूसरा property भी hold करता है. Next, existence of identity. From the table, we see that 1 into x is equal to x into 1. This is equal to x for all x in G. Therefore, 1 is the multiple identity of G. देखो ओमेगा into 1 ओमेगा, ओमेगा स्क्वायर into 1 ओमेगा स्क्वायर, 1 into 1 हो गया 1. तो ये प्रॉपर्टी होल्ड कर रही है. नेक्स्ट, एग्जिस्टेंस ऑफ इनवर्स. फ्रॉम द टेबल वी सी दैट 1 into 1 is equal to 1. ओमेगा स्क्वायर into ओमेगा is equal to ओमेगा into ओमेगा स्क्वायर. This is equal to 1. Therefore, inverse of 1 is 1. Inverse of omega क्या हो जाएगा? ओमेगा स्क्वायर यहाँ से. And inverse of omega square is omega from here. It implies that inverse of each element of G exists in G. तो ये existence of inverse भी हो गया. Next है commutative property. Since 1 into omega is equal to omega into 1, this is omega. 1 into omega square is equal to omega square into 1, this is omega square. Omega into omega square is equal to omega square into omega, this is equal to 1. It implies that AB is equal to BA for all AB in G. देखो AB is equal to BA आ रहा है. Therefore, commutativity holds in G. So, G is an abelian group with respect to under multiplication. Commutativity can also be seen through the composition table as follows. If composition table is symmetric as a matrix, then commutativity holds. If composition table is not symmetric as a matrix, then commutativity does not hold. But this procedure to examine whether a binary operation is commutative or not is convenience only when group G have finite number of elements and this number is sufficiently small. तो ये कम संख्या में है इसमें एलिमेंट्स, इसलिए हम लोग इस टेबल से चेक कर लिए. अदरवाइज हम लोग को ट्रेडिशनल मेथड से चेक करना होगा. तो इसके बाद है तुम्हारा, इसके बाद नेक्स्ट आता है तुम्हारा परम्यूटेशन ग्रुप. तो ये हम अगली क्लास में करेंगे. अभी के लिए तुम लोग इसको इतना नोट कर लो. फ्रॉम definition of group and some examples of group, Abelian including Abelian groups also.